Hi everybody, in this video, let's look at some questions from your Form 4 App Math Chapter 7 Coordinate Geometry. All the questions here are taken from SPM 2022. Now, let's look at this question. This is from SPM 2022, Paper 1, Section B. Diagram 11 shows a line segment AC. Okay, we have a line segment AC over here. It is given that point B divides the line segment AC in the ratio of M is to n. This is m and this is n. Okay, we want to show that y is equal to this. Okay, in the previous video I showed you about this one also, right? Now let me draw two triangles first. These two triangles, they are similar triangle. Now since I want to show only the y coordinate part, so I will look at this one. Look at the vertical distance. So how do we get the distance here? This is y2 minus y, right? y2 minus y. You will get the length here. y2 minus y. Okay, how about this? The length here. y minus y1, right? y minus y1. Okay, now I can start to form an equation. y2 minus y over this one over this, y minus y1 is equal to, the ratio is m is to n, but I put the y2 minus y on the top, so it will be n over m. Now just do cross multiplication. M y squared minus m y is equal to n y minus ny1. So this one you have to be more careful because you have a lot of y here. You have y2, you have y, and you have y1. So our purpose is to isolate the y. We want to show that y is equal to this. Okay, so this one, I'm going to move it to another side. So my2 plus ny1 is equal to this one, just copy. This one move to here, become plus my. Okay, now my square, not square, my2 plus ny1 is equal to, here I'm going to factorize y out, y times n plus m. Okay, now almost here. So I'm going to move this because y times this, move to another side, become dy, right? Okay, so my2 plus ny1 over n plus m is equal to y. Okay, so I just arrange all the terms, follow this this way. Okay, y is equal to ny1 plus my2 over m plus n. Because this is plus, you can write this first or write this for the same thing. Same thing here. This is plus n plus m, and m plus n is the same. Okay, now we have shown the y is equal to this. Okay, this is the answer for part A. Now let's look at the second part, part B. It's given that P, this is a moving point, x, y move such that its distance from R, it says from R, this is the coordinate of R, is 2.5 times its distance from y-axis. So how do we get its distance from y-axis? So let me draw a diagram to help you to visualize the situation. Let's say this is y and this is x, right? Vertical axis, horizontal axis. Let's say I have a point over here. Let's say the point here is 2, 2, 3. Okay, so if I ask you what is the distance from y-axis, will be here, right? Which is the x coordinate, right? Okay, so now if you understand this concept, now we can start to form an equation. Okay, so distance between 2 points, x1 minus x2 square plus y1 minus y2 square, and then we square root the whole thing, right? So x, let me move this one over here. Okay, x minus 3 over 2 square plus y minus negative 1 over 2, it will become plus square root. Okay, square root this whole thing. Now here we will be able to get the distance between P and R is 2.5 times of this. So what is the distance here? So as I told you just now, if you want to find the distance from y-axis, it will be the x coordinate, right? So I will write x. So maybe you will start thinking, so how about teacher if it's over here? Let's say it's over here, let's say the coordinate is negative 2, 3. So I cannot say that the distance is negative 2, right? Because distance cannot be negative. But it's okay, because later on, we will be squaring. We will square both sides. When we square both sides, even though negative, it will also become a positive, right? Okay, so now the next step, I want to get rid of this square root sign. So what I'm going to do, I'm going to square both sides. So here you square it, here you square it. No more square sign. Here you need to square also. Okay, so here let me copy first. Okay, 2.5 square, 2.5 square, you will get 25 over 4, and this one is x square. Now what we are going to do next is just expand this one. So x square minus 3x plus 9 over 4. Okay, let's say if you cannot do the expansion this way, you can just do it like this. Just expand it one by one. X times x, x squared, times this one, negative 3 over 2x, negative 3 over 2x, positive 9 over 4. Now, x squared, you can just press your calculator. Negative 3 over 2 minus negative 3 over 2, you will get negative 6 over 2, which is equal to negative 3. It's actually the same thing. Okay, now I'm going to do, as I told you before, if this is minus, when you do the expansion here, remember to put a parenthesis. But this is plus, you don't want to put a parenthesis, it's okay. I also use the same formula to help me do the expansion. This is a minus b square formula. This is a plus b square formula. I hope that you still remember these two formula, because we always need to use it. What's the formula for this one? So this is a square plus 2ab plus b square, right? Okay, how about if we have minus a square minus 2ab plus b square? Okay, now y square plus 2 times this, you will get y plus this one square 1 over 4. Okay, so this one I'm going to move to another side, become minus 25 over 4x squared. Okay, now we just need to simplify the like terms. So now let's look at x squared first. X squared and negative 25 over 4x squared. Just press your calculator. 1 minus 25 over 4. You will get negative 21 over 4. And don't forget to write the x squared. Okay, then plus y squared minus 3x plus y. Now, let's go to the constant part. Plus 9 over 4 plus 1 over 4. So you will get 10 over 4, which is equal to 5 over 2 plus 5 over 2. Okay, so now this is the locus of point P. So if you don't want to see a fraction like this, you can multiply the whole equation by 4. But if you want to multiply by 4, make sure you multiply every single term correctly. So this will be negative 21x squared plus 4y squared minus 12x plus 4y plus 10 is equal to 0. Okay, this is the locus of point P. Okay, now let's look at the last part of this question, part C. Diagram 12 shows the point P, Q, R, and S on the Cartesian plane. Okay, It's given that w, x, y, this is a locus. It keep on move such that its distance from point P and point R is always equal. So we know that this is actually perpendicular. This locus of point W will actually be the perpendicular bisector of PR, right? Okay, let me draw the line for you. And here will be 90 degree. Okay, if the area of the quadrilateral PQRS is 60 square unit, find the y-intercept of the straight line PQ. Means that we want to find the y-intercept over here, this one. Okay, now let me draw a quadrilateral, draw the quadrilateral for you. So it's over here. Now, since that the locus of W is a perpendicular bisector of PR, so we know that because it's all the distance from P and R is always equal. This means that this and this same length, right? And this is 90 degree here and here, same length, and this part and this part same length as well. From this, you actually know that this line is going to divide this quadrilateral into two equal halves. Okay, now if this is 60 square unit, then we know that half of it will be 30 square unit, right? Okay, so how do we get the area of this triangle? We can use Soule's formula, right? 1/2. Okay, I'm going to arrange it anti-clockwise so that it will be positive. So this, I don't know, I want to find. I suggest, I don't know the y coordinate, but the x coordinate definitely will be 0. Okay, I just let it be 0y. 0y. And this is 8, 9. This is 2, 12. And then don't forget the first pair and the last pair always the same. You have to repeat again the first pair. Okay, now this will be equal to 60 divided by 2. This is 30, here is another 30. Total up, the area for this quadrilateral is 60. Okay, so now I just times 2 over here, then it becomes 60. Modulus 0, y, 8, 9, 2, 12, 0, y. Okay, is equal to 60 over 2 is actually 30. 30 times 2, you will get 60. Okay, let me calculate again. Okay, correct. Now, so how do we do this part? Okay, so 0 times 9 plus 8 times 12 plus 2 times 1. And then for this part, all will be using minus. Minus 8y minus 2 times 9 minus 0 times 12. Okay, this is equal to, and don't forget we have the modulus sign. Okay, so here we just simplify it. So this will be 0. So 8 times 12 is equal to 96. 96 minus 2 times 9 is equal to 78. Okay, 78. Now let's go to the unknown part. 2 minus 8 minus negative 6y. Okay, so actually we have two answers here, but since I arrange in this anti-clockwise, right? So definitely I know that this one is positive. Okay, if in other situation, I mean, let's say for example, you don't have this diagram, it's not about this question. The question asks you to solve this one. Actually, we have two possible answers. Okay, now let me show you the two possible answers. Modulus of this equal to 60. We know that inside maybe it can be 60 or it can be negative 60, right? So 78 minus 6y is equal to negative 60. 78 minus 6y is equal to 60. So what we are looking, what will be our answer will be this one, not this one. Okay, now, so this is 6y equal to 78 plus 60. You get 138. So 138 divided by 6, you get 23. Okay, so this is not the answer that we are looking for. Why? Because this is 8, 9. So it means that here is 9. The p is lower than this line. So definitely it cannot be 23, right? Not accepted. Okay, now let's go to this one. So 6y is equal to 78 minus 60 will be 18. So y is equal to 18 divided by 6. Y is equal to 3. Okay, so the y-intercept is equal to 3. Okay, this is the answer for part C. Okay, now this question was also taken from SPM 2022. This is paper 2 just now. One is paper 1, all right? Paper 1 section B. So this is paper 2 section A. Question number 2. Now, diagram 1 shows two straight lines. The equation of the straight line RS. Let me label the equation first. Y plus 2x plus 3 is equal to 0. And PQ and RS, they are perpendicular to each other. Okay, we want to find the equation of PQ. When you are asked to find the equation of a straight line, always remember two things. You need gradient and one point. So we have the point here. Now we need gradient. So how do we get the gradient here? We cannot use y2 minus y1 divided by x2 minus x1 because we only have one point, right? But it's okay. Since we know this is 90 degrees, the gradient here times the gradient here will be equal to -1. So if we can get the gradient here, then we will be no problem to get the gradient of PQ. Now, let me get the gradient of RS first. Y plus 2x plus 3 is equal to 0. So if I want to express it in the form of y equal to mx plus c, the gradient form, it will be y equal to -2x minus 3. From here, I know that the gradient of RS is equal to -2. Now, since they are perpendicular to each other, m1 times m2 is equal to -1, right? So gradient of PQ times gradient of RS will be equal to -1 because they are perpendicular to each other. Okay, now gradient of PQ I don't know. I want to find gradient of RS is equal to -2, and they are equal to -1. When you multiply together, you will get -1. So gradient of PQ is equal to 1 over 2. Now we have the gradient. We have the full coordinate of one point which lie on the straight line that we want to find the equation for. Then we will be very easy to get the equation of PQ. So you can use y equal to mx plus c to have get the equation, or you can get the you can use this formula. Y minus y1 is equal to mx minus x1. Now I'm going to use this formula at point p, not pq, at point p. Y minus y1 is equal to m x minus x1. Okay, negative negative it become positive, and here it's just negative negative positive. Okay, now y plus 2 is equal to, do some expansion over here, 1 over 2x plus 4. So y is equal to 1 over 2x plus 4 minus 2, you will get 2. Okay, so this is the equation of the straight line PQ. Let me write down the equation. If you want to do one more step, you want to multiply by 2, it becomes 2y is equal to x plus 4. This is also correct. Both are correct. Okay, y is equal to 1 over 2x plus 2. This is the equation for the line PQ. Part 2. We want to find the coordinate of Q. So the Q is the intersection point of this and this. So we just solve it simultaneously. So the first equation is equal to y equal to 1 minus 2x plus 2. Okay, let this one be the first equation. And second equation is y is equal to, so I'm going to move the 2x and 3 go to another side, it becomes negative 2x minus 3. Second equation. So since these two are equal to y, right? So I can say 1 is equal to 2. First equation is equal to second equation. So this means that 1 over 2x plus 2 is equal to negative 2x minus 3. Okay, I'm going to group the x here. 1 over 2x plus 2x. Negative 3, remember the negative, minus 2. Okay, so this is negative 5. Okay, so x is equal to negative 5 divided by this. You can press your calculator. So, or if you want to change the multiply, then you have to flip over the numerator and denominator. Okay, x is equal to negative 2. Okay, once you get the x coordinate, you can bring this into this or this one, totally up to you. Then you will be able to get the y coordinate when x is equal to negative 2. Okay, I'm going to substitute this one into the first equation. So y is equal to 1 over 2 times x plus 2. Okay, so when you cut this way, you have to be more careful. This is negative 1 plus 1. Okay, so the y coordinate is 1. But you cannot stop here because the question asks for the coordinate of Q. So your final answer must be in the coordinate form. Okay, so the Q coordinate of Q will be negative 2, comma 1. Let me label over here. Negative 2, comma 1. Maybe later we need to use it. Now let's go to the last part, part B. The straight line PQ, this PQ is extended to point T such that PQ is to QT is equal to 3 is to find the coordinate of T. So let me draw this line horizontally like this, so easier for you to see. This is P and this is Q, extend to T. Okay, P, the coordinate of P is negative 8, comma negative 2, Q, negative 2, comma 1, T, we don't know, we want to find. Okay, I just let the coordinate of T be x, comma y. You can use other variables. Okay, so PQ is 3 parts and the QT is 2 parts. Now, how do we get the coordinate of x and y? So I hope that you still remember the formula to find the coordinate of a revisor of a line segment. Negative 2, comma 1 is equal to 3x plus 2 times negative 8 over 3 plus 2. This is for the x coordinate. Now y coordinate 3 times y plus 2 times negative 2 divided by 3 plus 2. Okay, now we just compare both sides. This is equal to this and this is equal to this. So 3x minus 16 over 5 is equal to negative 2. So 3x minus 16 is equal to negative 10. Negative 2 times 5, negative 10. So 3x is equal to negative 10 plus 16, which is equal to 6. X is equal to 6 divided by 3, which is equal to 2. Now, do the same thing for the y coordinate. This is equal to this. 3y, positive, negative, negative 4. This is 5, is equal to 1. So 3y minus 4 is equal to 5. 1 times 5, you get 5. So 3y is equal to 5 plus 4, which is equal to 9. And y is equal to 9 divided by 3, and you will get 3. Now we know the coordinate of t is equal to 2, 3. Okay, that's all for this video. See you in the next video. Bye bye.